A photon is a quantum of the electromagnetic field. It is created whenever energy is transferred in a way that involves that field. The main ways photons are created: 1. Atomic and molecular transitions. An electron drops from a higher energy level to a lower one. The energy difference is released as a photon. This is how light bulbs, lasers, LEDs, stars produce light. 2. Thermal radiation, blackbody radiation. Any object with temperature above absolute zero emits photons. Hotter objects emit higher energy photons. Stars, fire, your body, infrared, all do this. 3. Particle interactions. Electron-positron annihilation. 2 gamma-ray photons. Bremsstrahlung, electrons slowed by nuclei. Synchrotron radiation, charged particles in magnetic fields. 4. Nuclear and particle decays. Gamma decay from excited nuclei, particle collisions and accelerators. 5. Vacuum fluctuations, quantum field theory. Virtual photons appear briefly. Under special conditions, Casimir effect, Hawking radiation, they can become real too. How do photons experience time? This is where intuition breaks. Key fact: a photon does not have a valid rest frame in relativity. What that implies: time dilation formula becomes undefined at light speed. You cannot transform into the photon's point of view in a physical sense. However, mathematically, along a photon's path, a null geodesic, proper time, zero. That means, from emission to absorption, zero time elapses for the photon. Interpretation, carefully stated. A photon is emitted, it is absorbed. There is no internal clock ticking in between. So even if it travels 1 meter, 1 billion light years. From a relativistic standpoint, the interval is instantaneous along its world line. Important: this does not mean the photon experiences anything. Experience implies consciousness, which physics does not attribute to particles. 3. How do photons die? Photons don't die like living things. They are destroyed via interaction. Main ways photons cease to exist. 1. Absorption. An atom, molecule, or solid absorbs the photon. Its energy becomes electron excitation, heat, chemical energy. The photon is gone. 2. Scattering with energy loss. Compton scattering. Photon loses energy, lower frequency, eventually absorbed. 3. Pair production. If energy is high enough, photon converts into an electron-positron pair, requires a nearby nucleus or field, GRI, E plus E plus 4. Redshift to effectively zero energy. Cosmological expansion stretches wavelength. Photon energy approaches zero, still exists formally but becomes undetectable. 4. So what is a photon really? A concise modern view. A photon is an excitation of the electromagnetic field. It has no rest mass, no proper time, no internal aging. It exists only as long as it is in flight between interactions. 5. Summary, plain language. Created when energy is emitted electromagnetically. Does not experience time, proper time, but zero. Destroyed when absorbed or converted into matter. For the photon, emission and absorption are effectively the same moment. A final philosophical note, optional but important. Photons sit at the boundary between process and object, event and thing. They are not little bullets moving through space. They are events connecting interactions across space-time.